Okay, today's lesson is on degrees, minutes, seconds. That's what this DMS means. And we're going to look at converting from decimal degrees into degrees, minutes, seconds. So before we do that, I'm going to show you a short video that kind of explains how they work in regards to GPS coordinates.
Hey Brain Stuff, I'm Jonathan Strickland. So you've probably seen geographic coordinates like these before, maybe on a GPS device or maybe scrawled in a mysterious note you found in the glove box of a rental car. But if you never knew exactly what they meant, fear not. It's actually pretty simple, and we are here to make it all clear. When you see a set of geographic coordinates looking like this, or like this, you're reading latitude and longitude. Latitude represents north-south location, and longitude represents east-west location, usually listed in that order. By combining them, you can pinpoint any spot on the surface of the Earth. These coordinates aren't expressed in units of distance, but in degrees. Why? Because the Earth is a sphere. Imagine a line running from the equator to the center of the Earth, and then another line running from the center of the Earth to the North or South Pole. These two lines make a 90-degree angle. All latitudes in each hemisphere can be represented by drawing a third line somewhere between them. So the equator would have 0 degrees latitude, and the North Pole would have 90 degrees north latitude, and a location halfway between the North Pole and the equator would lie at 45 degrees north. Same thing for the southern hemisphere, except you'd call it degrees south. For more precision, each degree of the Earth's surface is divided evenly into 60 minutes, and each minute is divided into 60 seconds. If you need to get even more specific, you can just add decimals to your seconds. Alternately, you can write the whole coordinate in decimal notation. To do this, you have to convert minutes and seconds, which are base 60, into our regular base 10 counting system by dividing each unit by 60 and then summing them up. The results sometimes look counterintuitive, but if you're skeptical, you can pause the video and check out the math. Lines of longitude, also called meridians, run north-south and are used to measure position along the east-west axis. While the lines of latitude run parallel to each other, meridians converge at the poles and spread farthest apart at the equator, like the segments of an orange. Longitude is also measured in degrees, but its 0-degree line is known as the prime meridian, and it runs from the North Pole to the South Pole through Greenwich, England. So, if the prime meridian is 0 degrees, the opposite side of the Earth is 180 degrees, and lines in between are expressed as degrees east or degrees west, between 0 and 180. Since the lines of latitude are parallel, each degree covers about the same distance the world over, roughly 111 kilometers. But because meridians converge at the poles, the distance covered in each degree of longitude varies hugely depending on your latitude. At 20 degrees north, which is about the latitude of Cuba and Hawaii, 1 degree of longitude is approximately 104 kilometers. At 80 degrees north, the latitude of Svalbard and northern Greenland, it's only about 19 kilometers. So, let's say I wanted to go dig up a stash of hot loot from some coordinates I found written in a mysterious note. Even without looking at a map, we can start to make a guess where this would be. Since it's 43 degrees north, it's almost halfway between the equator and the North Pole, again halfway being 45 degrees. And since it's 89 degrees west, it's almost halfway west between the prime meridian and the opposite side of the globe, halfway being half of 180 degrees or 90 degrees. Based on this alone, you can guess it's probably somewhere in North America. But if we use a map or a digital tool like Google Earth, we can zoom in and see these coordinates lead us to the U.S. National Mustard Museum in Middleton, Wisconsin? Huh. Well, what's the weirdest landmark you've ever found on Google Earth?
Okay, so I hope you learned at least something that you didn't know before. So let's look at how these conversions work. Okay, so this says some angles have decimal degrees, for example, 26.5. Angles with decimals can be expressed using degree, minute, second form, or DMS, in which the degrees are subdivided into minutes and seconds, kind of like time. So I want you to think about if you had 1.2 hours, what we would do to convert that to hours and minutes. That's not 1 hour and 20 minutes, right? We'd have to take the 0.2 and multiply it by 60 to see how many minutes that is. So 1 degree is just like 1 hour. It is 60 minutes. 1 minute is 60 seconds, okay? So then 1 degree, if I wanted to get it to seconds, I'd have to take my minutes and multiply them by seconds. So that's going to be 60 times 60. So that is 3,600 seconds. So our symbols for degrees, minutes, and seconds. Degrees, well, you know what the degree sign looks like. Minute is an apostrophe. Second is a quote. Another use of these two notations is feet and inches, but this is not feet and inches. This is degrees, minutes, seconds. Okay, so let's look at how we're going to convert decimals to degrees, minutes, seconds. So I have 31.875 degrees. Okay, so the 31, I know it's going to be 31 degrees. So I can go ahead and put this is 31 degrees. Then I'm going to have to break this up. Okay, I'm going to put 0.875. So that 0.875, I'm going to have to multiply it by 60 to see how many minutes that's going to be. So when I multiply that by 60, okay, so I'm going to use my calculator, and I'm going to do 0.875 times 60. That gives me 52.5. This is 52.5. Okay, so then I have to use this whole number, so this is going to be 52 minutes. And then I have to figure out my seconds, so I take that decimal part, 0.5. If I multiply that, it's already been multiplied by 60 once, so I multiply it by 60 again to get seconds, and I get 30. So this would be 30 seconds. So 31.875 degrees is 31 degrees, 52 minutes, and 30 seconds. Okay, and our seconds aren't always going to come out to whole numbers, so we'll look at what we're going to do with that. All right, so let's look at number 1. I've got 15.48 degrees. So I know this is going to be 15 degrees, and then I'm going to have to figure out the minutes and the seconds. So I'm going to take this 0.48, so I'm going to multiply 0.48 times 60. Okay, so that's going to give me 0.48 times 60, gives me 28.8. So I get 28.8. Which means I take this whole number then, this is going to be 28 minutes. I take this 0.8, multiply by 60 again, 0.8 times 60, and I get 48. 48 seconds. Okay. So let's look at number 2. 150.2 degrees. So I know that this is going to be 150 degrees. I'm going to take the 0.2, I'm going to multiply it by 60. So 0.2 times 60 is 12. So I get 12. Well, there's no decimal after that, so that means I don't have a whole number of minutes and no seconds. So it's 50 degrees and 12 minutes. So you don't have to have seconds on there. All right, so I'm going to give you a second. I want you to do number 3. You're not going to get a whole number of seconds. I'll tell you that right now, but as I work through it, I'll show you what that is. So work on this without actually just copying mine down, because I'm not going to talk you through it until the end. If you're not finished yet, then pause and then start it back up when you're done. I'm going to talk you through it. Okay, so I knew this is going to be 273 degrees, so I multiply the 0.771 times 60. I got this 46.26. So that gave me 46 minutes. So then my 0.26 times 60 gave me 15.6, so my seconds are in decimals. That would be the only one that I have a decimal on, up to 3 decimal places to be accurate. And depending on what you're using it for, it might have different rules that you round to the nearest whole number or whatnot, but there you go. All right, so then let's talk about converting degrees, minutes, seconds to decimal degrees. So we're going to go the other way. So this 73 degrees, 9 minutes, and 50 seconds. Okay? Therefore, I know I'm going to have to add this 73 degrees, right? And then I'm going to take 9 over 60. So I'm going to take this 9 minutes. I'm going to divide, I'm going to take the 9 minutes. I'm going to divide it by 60 because I multiplied by 60 to get it there. So I'm undoing. And then that's going to give me 0.15. Okay, so 9 divided by 60, 0.15. And then I'm going to do this 50. Now the seconds actually got multiplied by 60 twice. So here I have to divide by 3,600. When I do that, I do not get a pretty decimal. Okay, so 50 divided by 3,600 gives me that. And if you round at the wrong place, you're going to get the wrong answer. Sometimes you still get this right answer, sometimes you don't. So you have to be very, very careful on what you were actually doing with this. We're going to write this down. So what I would do in this case, if I was going to use the decimals, is you'd have to store it in your calculator. So we would have 0.0138 blah, 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 right? But if you don't have something that stores, it's fine, because we can just type it in with the fractions. Like, I don't have to actually get to the decimal part of this. I can just add to this. What I would really be doing is adding the 0.15 plus the 0.0138 blah, blah, blah that I have stored. But you can actually put these into your calculator as these fractions, and that's what I'll do on that first example. But in the end, what you're going to get is 73.164 degrees. So here's what I would suggest for this, instead of worrying about storing, because we haven't really talked about that, and I'm not so sure that you're all using calculators that you can actually store stuff in, and that's going to start getting you some wrong answers, and I don't want that. So what I would be doing here is I'm going to have to take this 315 degrees. I'm going to add to that this 8 minutes. Well, the minutes get divided by 60, 8 over 60. There are no seconds, so that's it. And the calculators that most of y'all are using, you can put this in. So I can just type it in like that and have 315 plus 8 divided by 60. And then it'll just take care of everything together. So I get 315.133333 repeating. So this gives me 315.133 degrees. So let's look at number 5. So this is a negative number, but I'm still going to add everything together. You don't turn this into subtraction or anything. You just let that negative sign carry along through everything. So this is going to give me negative 121 plus, I'm going to take this 4 and I divide it by 60. That reduces, I don't even care because I'm about to put it in the calculator, plus 45 divided by 3,600. Okay, so to simplify things, like, not this kind of simplify, to make things easier on yourself, when you put this into the calculator, don't put the negative in. Just go ahead and write it over here, and then we're going to type all the numbers in. So it's going to look like this, 121 plus, now if you're using one of the Desmos or Delta Math calculators, yours is going to look much prettier than mine because the fractions look good. 4 divided by 60 plus 45 divided by 3,600. Just do it all at once. and then the calculator takes care of all of it for you right there. So remember, we already carried our negative sign over. I round to the correct decimal place, and I get negative 121.079 degrees. Did I put my degrees on this one? No, I didn't. Okay. All right, so I want you to do number 6. I'm going to do it without talking you through it, so don't just copy mine down. Get yours done, and then check yourself with me. Okay, so once you get done, check yourself with me. You should have plenty of time left in class to get most or all of this done pretty quickly. Okay?